biologist, I spend most of my time thinking about and studying the largest animals to have ever lived. But being a whale biologist, you quickly figure out that you also have to have a great appreciation and spend some of your time thinking about the smallest organisms that are in the water that are the reason that the largest animals in the water are there. So I want to talk a little bit about plankton, and we'll focus especially on krill, which is what everything down here in Antarctica is eating. So plankton is defined as an organism that is unable to swim against a current. So some of them typically have the ability to move a little bit, but the ocean determines their movement more than their own abilities to do so. Some animals spend their entire lives as plankton, and some spend just a short time of their lives, maybe the first year or two, as plankton, and then settle out of the water column as something like maybe a sea urchin or a sea star. Does anyone know what the largest animal that's still considered plankton is? Any guesses? I'll give you a hint. It's a fish. Jellyfish. Yes, jellyfish are, although that's not actually the fish I was going for, but this fish is the largest bony fish. It's a mola, or an ocean sunfish. They live in temperate tropical waters. They do have the ability to move. They have two fins that they can kind of flap around and go through the water, but their movements are more determined by ocean currents rather than their own movement, so they are considered plankton. Largest species. How large are they? They're about, I think, largest about 5,000 pounds or about 2,200 kilograms. Yeah, they're the largest bony fish in the oceans. So two main types of plankton. We have phytoplankton, which are tiny, microscopic, often single-cell plants, and then you have zooplankton. So oftentimes in marine science we talk about productivity. And by productive, if an area is productive, we mean that there's a whole lot of phytoplankton in the water that are then supporting the whole rest of the ecosystem. And you can have amazing different forms and different species of phytoplankton. And some scientists had way too much time on their hands and stained different parts of many different species of phytoplankton, different colors, and made this beautiful art. So Antarctic krill is the kind of zooplankton that we're interested in down here. It's what the penguins are eating, as you've seen from the color of the guano all over the rocks, and what the seals and the whales are also eating too. It's one of 85 different species of krill found in the Southern Ocean, and krill is also known as euphausids. And krill, they found, can live, they think, between about 5 and 10 years, which is really surprising, thinking about everything that wants to eat them. But it's really difficult to actually figure out in the lab even how old they can live, because they have this amazing ability to transform from the adult physical form to a juvenile physical form. This is typically after the summer season, they'll turn back into a 2-year-old juvenile, and you can't distinguish them that they've been an adult previously. So it makes it really hard to figure out exactly how long they're living to learn more about them. But that's really helpful when there's less food in the wintertime to eat for little krills. As a smaller body size, they can live off of their own body proteins. And in the lab, they found out that krill can live for more than 200 days of starvation. So pretty impressive critters. They are macroscopic. You can see them without a microscope. They're about 6 centimeters long, and they're only about 1 gram. And maybe some of you saw the krill that I found on the beach the other day in Yankee Harbor, really red pigmentation. And krill, I found out, fun fact, is a Norwegian word meaning whale food. You can ask the captain if that's true or not, but the British Antarctic Survey says that it is. So here's a better close-up, and you can see the internal organs there's my arrow right there, are colored green because they're eating that phytoplankton, which has the chlorophyll in it. And they have swimmerets along their body, so they're able to move up and down in the water column, but again, those ocean currents are going to move them around more than their own body movements. So all these animals are eating this species. It'd be a real pain to go after each individual 6-centimeter krill. Fortunately, they have a strategy to avoid predators, which then becomes helpful to the predators if they're concentrated. They form these swarms that can be kilometers long and tens of meters deep. Up to about 30,000 individuals could be compacted in a swarm like this. So it's safety in numbers for the krill, but it makes it really efficient for a giant humpback whale to come up and take a big gulp and demolish a swarm in 5 mouthfuls or something like that. Here's some data from a vessel survey looking at how much krill is in the water. You can see that it's not a uniform distribution all around the continent. There's some hot spots. And around the peninsula where we are, let's see if my cursor works. Cursor does not work. Around the peninsula, which you can see is at the top of the image, you see that orange and yellowish coloration. That's telling you there's more krill in the waters there, and also out into the Scotia Arc, again into the Drake Passage as we move to the east of the passage in between South America and the peninsula. You can see there's hot spots, especially around South Georgia. And again, this is all linking back to that nutrient upwelling that I talked about before, where you have nutrients coming up into the layers of the water column that have that sunlight, so then the phytoplankton can bloom, and all the krill and other species of zooplankton can eat all of that, and therefore support all the amazing wildlife that we get to see around us every day down here in Antarctica. So with that, I'd like to thank you for joining us for Recap and Briefing this evening, and bon appetit.